that we've completed our A matrix, and actually we can solve for n already now. So we have 4 factorial settings, 5 center point settings, and 4 star point settings. So that gives us a total of 13. And we can check by selecting this and looking at the count, it's 13. So this is our matrix A. Let me just transfer this here now. It's matrix A, and we are multiplying it by matrix B, and matrix B is just the variables themselves. So it's that's B0, B11, B22, and is equal to your Y matrix. Your Y matrix here is, let me just highlight this no, para hindi nakakalito. Y matrix is equal to the right side of our equation. So we have the first value is just the summation of the Y for the yield. Then for this next two, we actually have the square of the coded values now. So let's type in a new column. So let's call this x1 squared, x2 squared is just equal to square of this value. Drag this down. Take note, this is 1.999 now, which is very close to 2, and it should be equal to 2 because if you remember, this is just square root of 2. Okay, so if you want, you could just type this in as 2 now. And we can copy this one to this square of the coded settings for x2. So again, we can convert that to 2. Now we can do the second element now. So that's the sum product of x1 squared, which is this array, multiplied by your y array, which is this one. Similarly, we have sum product for the x2 squared, so that's x2 squared is this one, multiplied again by y. Okay, so now we have our A, our B, and our y matrices now. So if you remember from multiple linear regression analysis, and if you're taking ES21 or any linear algebra class, then you should know that if A times B is equal to Y, then the inverse of A, I'll say A prime, multiplied by Y should be equal to B. Okay? So let's first take the inverse of A. Now to do the inverse of A, we highlight a 3 by 3 cell where we want to input our inverse. We press equals n inverse, that's matrix inverse, and pick our matrix function A. Now to do array formulas in Excel, instead of doing a regular enter, we need to hold down shift and control now. So if we hold down shift and control like so and press enter, we should be able to fill out the 3 by 3 matrix. So if you do not enter, or if you do not press down shift and control, nangyari is you only fill out the first element now. Okay, so this is A inverse, and we are now computing for B, which is just equal to A inverse multiplied by your Y. So to do that, let's first select our our 1 by 3 matrix here, and type M mod. The first array is A inverse multiplied by your Y array. Okay, again, press Control and Shift, and press Enter. So you should get this value. Now, this is our B0, this will become our B11, and this is our B22. Okay, so now we can complete this. This is equals B0 This is B11. This is B22. Okay? So, para hindi masyado manggulo, let me, pasensya na, medyo maingay sa labas, no? So, hanggang 2 decimal para medyo malinis tingnan, no? So, let me remove all of these equations, no? Para hindi masyado magulo. And let's look again at the second order form, no? And let me copy this. So our second order equation should look like this, no? Let me bring down. It should look something like this. So y is equal to b naught. B naught is 79.5. Our b1 is 0.04. Our b2 is, this is negative, let's change this to minus, negative 0.16. b11 is equal to, again, negative, so that's 0.57, and let's convert this to minus sign. b22 is negative once more, so minus 0.19. This is a minus sign, minus. This is and last is b12, which is 1.15. Alright, so this is our final second order model, and now we can proceed to optimizing this model. So if this were a linear model, if you follow the steps, it should be, if it was a linear model, then you do MSA, or method of series effect. But for second order equations, you cannot do let me just check if we got the same answers now. Okay, so it's the same answer. Okay, so again, if you are doing CCD, you produce a second order equation, and for second order equations or higher order models, MSA is not applicable anymore. So we need to plot the 3D optimum point. And to get that, we actually just have to do the partial derivative. So if you remember math, I think this is discussed in math 53 now, or 54, I think. To optimize a particular equation, you just need to get the partial derivative. Okay, so for example, if I want to optimize x1, then I just get dy, the partial derivative of dy over dx1. Then if it's x2, get the partial derivative of dy over dx2, and so on and so forth. So if you can't remember how to do partial derivatives, then maybe you should review your notes now on how to do them. So that's how you do your optimization for 3D for higher order models. And if you have a powerful software, you can actually plot the surface of the model, the higher order model. It should look something like this. And if some softwares from the 3D model, you can also plot the contour. Alright, so that ends our lecture for CCD, and I wish you good luck in the exam this Monday. Again, it's 9 to 12, and we'll be having late exams for those with morning classes. Siguro, if you want, no, we could have a review session, sort of consultation sa Friday siguro. I'm free whole day on Friday, so maybe you could email me if you want a class consultation. Okay, so good luck guys, and have fun studying. Kalimutan like, subscribe.